I didn't write the symbol here, but what was the math you've been doing all day? Isn't that times? Isn't that? Oh, let's not do that. That makes it way more messy. We're gonna do it even easier this time. You can. Let's not. You can. Let's not. It's gonna make it way messier if we do. That's multiplied, right? That's multiplied. We've been doing multiplication. Remember over here, multiply, all these multiplications. It's times. I didn't write it in there because when you stick numbers next to parentheses, a lot of times you don't have to write it. Malia. So we divide both sides by the 2,000 to get rid of that 2,000. Divide by 2,000. Divide by 2,000. Grab a color marker. I know, this might be an algebra review, and it's good. It's good if it is. It's the only algebra we're going to have to do. On inflation. This is the same inflationary math every single time you do it. I gotta move that camera so it's pointing at the right place. It might not be. It's no. There we go. Okay. On the right side, or excuse me, on the left side, my apologies. On the left side, those just divide off, and you're left with 1 plus r, and that's still squared. That squared's still there. We'll deal with it in that. I promise. We'll deal with it in that. What's this equal to? What's $2,400 divided by $2,400 divided by $2,000? 1.2. 1 point. Here's a trick question. What's the unit on that? Trick question. It's not dollars. Why is it not dollars? Why? You got dollars top and bottom. This is Math 98, isn't it? When you divide dollars by dollars, the dollar signs divide off. That's unit analysis for Math 98. The only thing left is the number, which is, I heard 1.2. Is that what I heard from folks? No. This squared equals 1.2. What we just figured out, Natalie, we're one step away, girl. We're one step away. What we just figured out is, what's that as a percentage? What's that as a percentage, y'all? Don't overthink this. Move it 2 places. It increased 120% over 2 years. What I want to know now is, hold that thought. Keep that thought in your mind. Some of you are thinking that's going to be 60% a year, right? Keep that thought in your mind. Keep that thought in your mind. This just ties into Malia's question from before. That's squared. That's squared. Suppose I tell you some number squared equals 16. What would you tell me that number is? Something squared equals 16. What would you tell me that number is? Josie came, and Natalie very quickly said 4. How do you? Because 4 times 4 is 16, right? Is that cool? Okay. Let's try another one. Suppose I asked you some number squared is 81. That's quick. 9. Damn. Some number squared is 1. 1. 1 times 1 is 1, right? 1 1. Some number squared is 64. Cool. How about some number squared is 91? Not nice. Not nice. 81 was 9. 100 would be 10. So it's somewhere between 9 and 10. Can you figure out what it... Shannon's going for a calculator. Yeah, you are. Because we have a function on our calculators that'll do this, don't we? It's called the what? The square root. Do you take the square root of the number? We could have done it with all the other ones we did too. What's the square root of 91? It's not nice, but what is the square root of 91? Hell, you can even ask Google if you want to. Let's just ask Google. Let's ask Google. Hang on. Pull the screen down. I'm going to ask Google. What is the square root of 91? Oh! Thank you, Shannon. Come on. Green. Turn on. Screen. on, let me, oh! That, hang on, trying to get the damn projector to project. There we go, beautiful. Okay, Google square root of 91. Boom! There's Shannon's 9.539. And however many numbers you, how many, this is 9.5. Love this.
But then when you take a number and divide it over the 3 years, and you get 3.16.
These were just numbers I was making up, Shannon.
Okay.
Those are those numbers I was making up just because I wanted you to see you can come up with what. I really need like a production assistant on these days I record class. They're very, very ghetto. This number here, this number is squared to get 1.2. So can we just figure out what that number is by doing something to that number? Take the square root of 1.2, and what do you get? Ask Google. I don't know what it is. That's not a nice number. But you can ask Google, what is the square root of 1.2? I'm going to thank you. Malia, I appreciate you. Square root of 1.2. I'm just going to ask Google. And the nice thing about Google is you can just simply type it in your words. The square root of 1.2 is 1.095. Why is that 1 there again, everybody? Why is that 1 there? Remind me why that 1 is there. It's been the common theme of the past hour. Say that again, Mel. Yes, it's what it started with. Actually, believe it or not, it's a great answer. It's even more than that. It was 2000 in 2023, and it was whatever the hell it was, excuse me, in 2022, and whatever the hell it was in 2023, that 1 stands for the thing we started at. So now we know that 1 plus r, I'm going to put a squiggly equals just because it's not exact. We have to round this off. Can we go to 1.095? Is that okay if we stop there? What did I tell you to round to in the homework, in the 100th of a percent? So I'll go one more. 1.0954. That's 100th of a percent. See that 1 that's there? That 1 that's there? We can subtract it, get rid of it, or ignore it. So what, my friends, is the rate of inflation? 0.0954, which as a percent, Kristania, is 9.54%. So that means, dear friend, if we inflate it 9.54% from 2000 to 2023, and then inflate it again 9.54% from 2023 to 2024, we'll get to our $2,400. That's the 2-year rate of inflation. That's the 2 years. Josie, answer that question you got right now, or are you just taking it in? You're just taking it in. You're taking it in. Ask me questions. Say that again, Shannon. I heard. That's all you got to do. Tell me all you got to do.
I think you really put this over the top here.
What did you tell me? Why?
I mean, all you really have to do is you could take your 2,000 minus the 2,400, which is a $400 increase. And you take 400 divided by 2,000, which gives you 0.2, which what comes into what? 20%. And then
Divided by 2 because it's 2 years.
yes.
But that's not 9.5%. That's 10%. You see what I'm saying? This goes back to Malia's question. 10% would be. Check it out, Shannon. If I may, dear friend. If I may. Let's suppose we did it your way and solved inflation 10%.
No.
Let's just do that. Is that okay? So, in year, I'm going to use an Excel spreadsheet to do this. I think it might. We could see all 3 years this way. So I'm going to go year 2022, 2023, 2024. Okay, cost. We know we're starting at $2,000, right? Now let's suppose it's 10% inflation. 10% inflation. 10% inflation. This would be equal to 1.1 times that. I'm just increasing by 10%. That's the 0.1. Okay? So that's going to go to $2,200. Fair? Fair enough? Now I'm gonna inflate that by 10% again. We're too high. The rate of inflation isn't 10% because of what Malia said earlier. The dollar amount, how much did it jump from 2,000 to 2,200 dollar-wise? How much did it jump dollar-wise? $200. How much did it jump here? 220. It jumped an extra. We got 10% too much of a jump from 2023 to 2024. It's because you're thinking, and this is very easy to do. When you first think of inflation, Americans tend to think of it as additive. We want it to increase the same dollar amount every year. It doesn't increase the same dollar amount every year. It increases the same percentage every year. So we have to undo the percentages. So I know this might seem like it's over or extra, but this is what you have to do to actually get that rate. You actually do have to take, it's not subtraction or division, it's square rooting because you're undoing the multiplication. I know, it's like, it's kind of a brain, like, this is why I wish this whole thing was an entire class, rather than just shoving at the end of Math 105, I wish it was an entire class in finance. But that's how inflation works. It works multiplicatively, not additively. If it worked additively, your method would work brilliantly. If it said, oh, the price of eggs goes up 25 cents every year. So next year it's going to cost 25 cents more. The year after that's going to cost 50 cents more. The year after that's going to cost 75 cents more. It doesn't work that way. That's not how inflation works. It inflates as a percentage of the total. So no, and I appreciate your comment. The comment is great. Like, this seems like an awful lot of work. I can get close by just dividing. The problem is, the further out we go, the more off we're going to be. And we only got 2 years here. Watch what we're going to do. We're going to look at for the remainder of the class, we're going to look at minimum wage, which spans decades. We're going to see how that changes. Go ahead, Hannah. No, based on the field, you can give it a shot. Yeah, the last question is extra credit, which is basically explaining why you can't just take percentages, add them up, and divide by 2. So Shannon, I didn't realize you were going to ask that amazing question. But that extra credit actually addresses it exactly. Why can't you just add the 2 percentages I gave you and divide by 2 to get the percentage rate? Give it a shot if you want to. I thought of it as an extra credit. I threw it on there. I didn't want to go over it because I wanted to make sure we focus on this math today. This is the remainder of the math for the rest of the day. We're going to repeat it over and over again until it makes sense. Yeah. Which is literally the remainder of our 3 weeks together. You're compounding using multiplication. The word, I wasn't even going to use that word today, but you just used it, so we're going to now. No, it's okay. On Thursday, we're going to show what happens when we stick money into a bank account and then start applying interest to it like this, year after year. And you earn interest, and that interest is compounding multiplicatively. It's the same math as this. It's just inflation is a good way to start thinking about it. This is okay, that's good. I think you're all going to like it once we do a couple more. It'll make more sense the more we do it. It will, I promise. It'll make more sense the more we do it. But there is a little tiny bit of algebra that is necessary to get these values that we need. To get the values that we need. And Malia, back to your amazing question. Do you see how, when you apply the same percentage to different amounts, you get different dollar amounts? That should hopefully make sense. It's a percentage of a larger amount. That's going to be a larger amount at the end of the day. Oh, hey, you're talking to Esther. That's fine. I thought you were tying into what I was saying to Malia. You're good. Okay. Don't worry about the extra credit. If you don't like the extra credit, don't worry about it. We got about a 9.54% average rate of inflation. The crazy thing about average rate of inflation is that it ignores when the big jump happened. Remember our inflation rate from 2023 to 2024 was 14.36, huge jump. But the one from 2022 to 2023 was only 4.93. When you average them and do them both one after the other, you lose that big jump and make them both look the same. That's just the way average rates of inflation work. Which is why when anybody tries to use average rate of inflation to explain why, for example, a political party is doing things the wrong way, you got to go back and look more carefully. But I do want to focus today on this math. And what we're going to do now is, the remainder of time, we're gonna look at a meme from years ago that caught my attention. And this is actually what got me thinking about this, because it showed up in meme form. And I figure things that show up in meme form, generally speaking, this is how students seem to learn things these days. It's a little bit old, but Jobs with Justice is still around. Take a look at this meme. I'm giving you a set of class notes. We're going to work through the rest of the class together. Welcome. One more grade or two, this is here. Go. Take a look at that meme. Doc! You're telling me that on October 21st, 2015, October 21st is a very special day for Back to the Future fans, as is November 5th. There's some dates. Oh, sure. Oh, that's right. I forgot it was time. There's some dates from Back to the Future movies that are very, very special to fans. October 21st is one of them. Also November 5th, 1955, but that one isn't used here. I didn't make this meme, Jobs with Justice did. They made a claim. Doc, you're telling me that on October 21st, 2015, the paycheck of someone making minimum wage will be worth less than it was in 1985. Oh, God. Yes. First question in notes is, what is the meme trying to tell you? What's it trying to tell you? What's the complaint? Why does Jobs with Justice exist? In case you're unfamiliar with it, that's totally fine. Maybe some of you may have never heard of Jobs with Justice before. Doc, you're telling me that on October 21st, 2015, this is almost a decade ago now. I'll bring it up to speed on the warm-up for Thursday. The paycheck of someone making minimum wage will be worth less than it was in 1985? What's it trying to tell you? It goes back to one of the early ideas. I had them on the board. I had to erase it to make room for algebra. What's it trying to tell you, Hannah?
Making less money because inflation, even if the dollar amount is the same.
Say that all again.
Okay. You're making less money because of inflation, even if the dollar amount is the same, and power is lower.
I love that. So Hannah just wrapped up all. Let me ask you a question. Do you think minimum wage? We're going to do federal minimum wage, just FYI. We're not going to do state minimum wage. That gets too weird. Or maybe we'll do state minimum wage on the warm up next week, or next class. Federal minimum wage has been in the news constantly for the past 10 years. There's been a push for what number for the federal minimum wage? Anybody know what it is? That's what it currently is. But there's been, somebody just said it, there's been a big push to jump it to $15 an hour. That's been years. There's been a push to push it to $15 an hour. You already answered part of the question for the analysis for the James. I appreciate that. But the big point, Hannah nailed the big point. Do you think the federal minimum wage right now is higher than it was in 1985? Malia says yes. And I'm going to have you Google it. The answer is yes. So how could it be worth less? If it's higher dollar amount, how can it be worth less? Melissa, go.
Everything else is so damn expensive.
Because everything else inflated. Maybe minimum wage didn't inflate enough. So we're going to have to analyze minimum wage like we did in the warm-up we just did. We're going to have to collect some data and analyze it using inflation rate. And we're going to learn a cool tool to do this. We'll learn a cool tool to do this. Go ahead, Natalie, go. Question number 1.
Yeah,
The theme of the meme is, hey, it rhymes.
they're making less money even though.
They're making more money.
Making more money even though.
Isn't that great? It's hard. It breaks your brain to say that.
Like,
They're making more money, but those more dollars won't buy you as much stuff because everything else got more expensive. Remember the idea of taking $1 to the gas station earlier, Natalie? If you took $1 to the gas station in 1985, you could probably get a couple gallons of gas. You took $1 to the gas station in 2015, you couldn't even get a full gallon. Same dollar amount, buys less. What I want to look at now is this minimum wage argument. This has been an argument for 10 years. So I want to look at the math of it. I want to look at the mathematics of minimum wage. The mathematics of minimum wage, which is the same math we've already done. We've already done it right here. First thing I want you to do, and it sounds like James has already done this, and I appreciate you for doing this. If you haven't yet, number 2 says, what was the federal minimum wage in 1985? Natalie, these are just notes. You're not going to turn these in. Just hang on a minute. Yeah, just.
It changed.
In 85?
That's what this says.
What do you got? 335? Where did it change to, Alyssa? Let's Google it. Let's check. No, let's check. Hang on. Let's check. Let's check. Okay, let's see what it says here.
Never mind, I'm reading it.
Oh, it's okay. Actually, this is an interesting rabbit hole I don't want to drive down right now, which is the history of minimum wage. It hasn't always been there. Child labor laws were a large part of why it was instituted back in the 1920s and 1930s. I believe the first federal minimum wage was 25 cents an hour back in like 1928 or something. And then it jumped to 35 cents an hour a year later, which doesn't seem like much. But that was a huge percent, it was a 20% jump in the minimum wage, which is insane to think about. So, but yes, $3.35 an hour. Okay, $3.35 an hour. Everybody with me there? Okay, we've now figured out what federal minimum wage was in 1985. Now we're going to find what that should be worth 30 years later. So everybody Google now CPI inflation calculator. Everybody Google the CPI inflation calculator. You get a very, very easy to use government website, which is hard for me to say because most of the ones I've ever used are terrible. I know. It is very true. I even spelled them all wrong. Should be the first hit. Take a look at what you find. Oh, you found the history. Let's just track the changes. It looks like it changed 80, 81, 90. So it changed in 81 and didn't change again until 90. In 81, it changed to $3.35 an hour. It looks like it stayed all that way till 1990. So in other words, when they make the changes to it, Alyssa, they make the change and then it stays there and then it jumps up again. Yeah, well, I'm not saying it's the best way to show it. I'm just saying that that's the way they're choosing to show it. I don't know. I've never seen that page before. I don't know. I'd have to look at it with you afterwards. I've never seen that chart before, so I don't know. That's okay. We can go find, what's your source here? Department of Labor. Okay. Minimum wage history. Oh, Montana. That could also be state, not federal. I don't. Okay. So just so you know, I checked before I came in. It is $3.35 an hour. I can pull up the actual governmental link later if you want to see it, so you can trust it better. But I get what you're saying about not trusting the AI answer, because sometimes the AI steers us wrong. This right here, my dear friends, this allows you to put any dollar amount in. So let's put in 3.35. 3.35. I'm going to make the screen a little bigger too so you can see it better. 3.35. $3.35 an hour. It already has a dollar sign attached up there in the corner. Now, it does vary, as Alyssa brought up before, it varies month to month. So let's just pick the month we're in right now, which is November. Let's go with November 1985. November 1985. So something back in November of 1985 that cost $3.35, or we were paid $3.35, is going to inflate over 30 years. The question is how much to? I don't know the answer to that. We'll figure that out next. So we're going to say, let's change it to 2015 November. November, let's make the month match. Make it easy that way. November 2015. Notice how it says, has the same buying power. So something that cost $3.35 back then, according to economic inflation over 30 years, should cost how much now? $7.29. Just about double, it looks like. Just about double. She'll cost about twice as much. Everybody following that? So it just about doubled. Just about. 35 and 729. A little bit more than double. The next question is the most important on these notes. That was 30 years of growth. That means it inflated from 1985 to 1986, 86 to 87, 87 to 88, 88 to 89, 90, 91, 92, 93. I want to know, in this next question, what is the annual average rate of inflation in the U.S. according to these numbers we just got? What is the actual average rate of inflation based on the values you just got between? It says 2 and 3. Sorry, that's it. Oh, that is 2 and 3. 2 and 3. Yeah. I never articulated it. Y'all. Remember this example we did earlier? Remember this example over here? That was of the forms. Did you, Melissa? See? It's going to be almost identical to the math we just did. We just have to update it with our new information. This equation started life as this equation. I'm going to write a general form up here. This is what you can, if you want, you can take the general form with you when you go home and do the. I made a homework about the Boys in the Boat, that book and movie. I don't know if anybody saw the movie or read the book. It's okay. All the information's in the homework, but I want to make sure that you know how to do these kinds of math problems. Okay, you ready for this? This inflation right here. Oh! I should pay as my production assistant, Alyssa. Appreciate you. Thank you, Alyssa, for telling me to move the camera to the sideboard. I'm going to do it like this because I'm going to forget to come back again. Okay. Appreciate you. The model of inflation is start with the starting amount, starting cost, starting whatever. I'm going to put cost equals because right now it's actually a minimum wage, but it's a dollar amount, starting dollar amount. Then, that's the annual inflation. But we have to apply that annual inflation however many number of years there are. In the warm-up, we only did it 2 years. Now, we're going to do it 30, because we're going from 1985 to 2015 at the span of 30 years, yes? The span of 30 years. And that's going to equal to the ending cost. Every inflationary equation you do is going to look like this. Every single one is going to look like this. You're going to have a starting amount. In this case, it was $3.35, right? We started at $3.35 back in 1985. We end at $7.29 in 2015. And it took us how many years to get there? 30. All we got to do now is plug and chug. Let's plug and chug. Let's figure it out. Let's plug and chug. For the minimum wage example, starting cost, $3.35. That was like $2,000 over here. Much different because this was a fictitious number I made up and this is actually the minimum wage in 85. We don't know what that rate of inflation is. So I'm still calling it R. Is that okay? So I'm calling it R. Why is that one there, y'all? Why the hell is that one there again? Oh, somebody just said it, I thought. Yeah. Remember, every time you inflate something, more expensive. The 1 makes sure it comes forward each time. If the 1 were a 0, we wouldn't have inflation, we'd have deflation, which I've been told has happened over the years sometimes. Like in 2008, during the recession it happened, I believe during COVID it happened, where prices just drop. And that's usually a sign of economic instability. I don't really understand how because I'm not an economist, but generally speaking, a little bit of inflation is a healthy thing because it means your bank accounts grow too, not just the cost of things, but your bank accounts as well. It's all tied to the prime rate, which is kind of what we're solving for here. Say it again. Isn't it better than writing 1 plus r times 1 plus r times 1 plus r? And then, yes. Yes. You come around. James!
Yeah, but how do we 30 roots?
Don't you worry about that, brother! Well, I will do that in a second!
That's a lot of numbers.
It is, but Google can handle it like this.
Yeah.
Yeah, you already got it. Yeah, yeah.
Well, I don't got it, but
You know what I mean?
I've done it before.
I'm gonna show you 2 ways you can keep your favorite.
Okay.
Okay, what's the ending amount, y'all? 729. We just looked it up. I didn't know what that was. I never know what this is. This database pulls hundreds of years, 100, I shouldn't say hundreds. I think it's about 100 years of inflationary numbers. It's got them all stored. All we gotta do is go back and look. We use this thing all the time. Equation's done. We gotta do now is solve it. And we solve it the same way we solved this one. Exactly. Same way. What was the first thing we did here? That 2000 was in the front, was in the way. We had to get rid of it. So is that 335. Let's do it the same way. How do we get rid of it? 335. Also this side. Gotta make sure that equation stays an equation. Yeah, so it's a little bit of algebra, but it's not that bad because it's the same algebra every single time, which is kind of nice. Okay, you ready? Here we go. Divides off here, which means we just have 1 plus r to the 30th here. That's beautiful. That's beautiful. What's that equal? I can't do this in my head. What's that equal to? 2 point something? 2.18. 2.18? Let's call 2.18. Can we call 2.18? Is that okay? Does anybody know what that means? It's not dollars.
No.
2.18. Scott, what does it mean?
It's the difference of, that's not the cost, the difference
No.
of something.
You got it, man. It means minimum wage has inflated 218% over 30 years. Right? 218%, that's what that is. 218%. Or, said a different way, maybe I'll not use the word percent. Minimum wage now is 2.18 times higher than it was then. How about that? Is that better? That's better, isn't it? The same thing as 218%, but I think it doesn't quite sound as awful. Minimum wage now is 2.18% larger than it was then. Yeah. Okay. Is that enough? Well, according to Jobs and Justice, it isn't. They say that that's not worth enough. Well, my first question, take a quick pause. I want to know what that R is. If that has happened, oh, I know, I love this. Because earlier we just asked Google what was the square root of whatever number we needed, right? Right. Oh, okay.
So that's why I'm so,
Can you hit my hair too later? Because it probably has some
yeah.
forest woodland animals living in it.
Sorry that
You laugh because you know it's true. So when it's squared, it's a square root. If it's cubed, you can be a cube root. Anything more than cube doesn't have a special name. Fourth root, fifth root. But that's okay. It's the 30th root. Well, that's the 30th power, which means to get rid of it, we have to take the 30th root. So all you're going to do is you're going to ask Google, what is the 30th root of 2.18?